All right, boys and girls, welcome to Energy Transformation Notes, this Google slideshow. We'll talk to you about how energy is transformed from one form to another. So what is energy? Energy is the ability to do work. Energy cannot be created nor destroyed. It's just like the law of conservation of mass. It just changes form from one form to another. Anytime you're using energy, it just moves from one type of energy to another. Believe it or not, it never actually goes away. It just changes from one type to another. Remember, the law of conservation of mass is basically like the law of conservation of energy. Because energy can neither be created nor destroyed, it only transforms from one form to another. That means it changes from one type to another type of energy. There are several different forms or several different types of energy. Let's take a look at them. Chemical energy. This is energy that is stored in chemical bonds between atoms in a molecule. You have a bunch of different atoms bonded together in a molecule of atoms, and the chemical energy is what is holding them together. Here are some examples right down here: coal, wood, biomass. Biomass just basically means any type of plant or animal, especially anything that can burn or rot. Food, photosynthesis, natural gas, that's similar to propane, but not exactly. Cellular respiration, that means your cells are living. They're taking in oxygen, they're taking in energy from the food that you ate, nutrients, and they are living. Chemical batteries, here up here we have a battery. We have gasoline right here. Petroleum, that basically means oil, and that's where we get gasoline from. Propane, that's a gas that can burn. All of those are examples of chemical energy, right? They are chemicals that have energy, and when you break those molecules apart, they release the energy, and people have found ways to get that energy and put it to use. The most important of it is any food that we eat. Any food, plant or animal, your body is able to break those molecules apart, and that's how you get the energy out of them. We call it nutrition. Electrical energy. This is energy of electrical currents. It deals with the electrons in atoms moving from one place to another. This energy is carried through wires to give power to objects. Now, don't get confused right here. When this battery is just sitting on a shelf, or it's even sitting in a toy or a remote control, not doing anything, that's chemical energy. Once you start using it, then it turns into electrical energy. So a battery that is sitting alone and you're not using it, that's chemical energy, and it does have chemicals in there. Don't break the battery apart. It's got some nasty chemicals in there that can leak out and then cause corrosion and stuff. And then once you use that battery, the electricity goes through the remote control, or it goes through the wires in the toy, or whatever you're using. Nuclear energy. This is energy released by nuclear reactions. This is a little more complicated, and you might learn about this once you're in high school. It is used to generate heat, and then that heat can be turned into steam, and the steam can be used to turn massive turbines, which then create electricity. If you're ever wondering how these big old smokestacks right here, actually those are just big cooling towers. Nuclear energy produces a lot of heat, and they use that heat to turn water into steam, and that steam goes shooting down a tube, and it turns a big massive fan or propeller or turbine around that's hooked up to copper wire and magnets, and that is what creates electricity. It creates so much heat that they have these big old cooling towers. That is not nasty stuff coming out of the top. That's just plain old steam, water vapor up at the top. Mechanical energy means anything that is in motion, anything moving, right? Anytime something is moving, whether it's a machine or just a rock falling down a hill, or you're swinging a hammer, rolling a ball, anything that is moving. If you're sitting on a swing set or a seesaw, a teeter-totter, if you're on any kind of playground equipment, a car that is, anything that is moving, even if it's a tree moving back and forth in the wind, that is mechanical energy. It is the sum of the object's potential and kinetic energy. You'll learn more about that later on. Radiant energy is another word for light or electromagnetic waves. Remember, there are 7 types of light, 7 types of electromagnetic waves. radio waves, microwaves, infrared waves. The visible light, that's what you and I can see right here. Ultraviolet rays, X-rays, and gamma rays, all of those are types of radiant energy or light energy or electromagnetic energy. It's all basically the same thing. Sound energy. Sound is energy. Boy, you know that. If anyone ever cranks the radio up real high, the speakers are blasting away. Sometimes you've probably been sitting next to a car that had the speakers going and they're so loud they even hurt you. You can feel them shaking. That's energy. It moves through a substance. Sound cannot move through a vacuum. It has to be touching other atoms in order to move. So it can move through the air because the air is made up of atoms. It can move through, if you put your ear up against a piece of wood and somebody knocks on the other end of the wood, you're going to hear that sound coming through. If you put your ear on a piece of metal, like say maybe a car, and somebody is at the other end of the car knocking on the car with their fist, you're going to hear it come through the metal. If somebody is underwater and they're making a sound underwater, you'll hear that. But if you're out in space, there is no air, there is no metal, there is no water, there is no wood, there is no nothing for the sound to go through. So if you're in space outside of a spaceship, because the spaceship has air in it, but if you go outside of the spaceship and you take your helmet off and you yell as loud as you can, somebody else is not going to be able to hear you because there is no air for that sound to go through. Not only that, but you're going to die because you took your helmet off in space. So don't take your helmet off in space. Of course, when you're in the spaceship, that's different because the spaceship is filled with air and the sound can go through air. Thermal energy just means heat, like thermometer measures your temperature. Thermostat controls the heat or coldness in your house. A thermos is a container for keeping stuff warm. Thermal underwear is the long underwear that some people might use, especially with it being cold recently. Thermal means heat. Energy transformations. The change of energy from one form to another form is called an energy transformation. Transformation just means to change. The principle in physics, which states that energy cannot be created nor destroyed, is called the law of conservation of energy. It's just like the law of conservation of mass. The law of conservation of mass says that no matter can be created nor destroyed. It's only changed from one form to another. And the law of conservation of energy says the same thing. It never goes away. It just changes from one form to another. Just like in just like in a food chain, energy goes from one organism to another. Not all of the energy from the previous level was transferred to the consumer. Some energy is lost or transferred, such as heat, okay? Or it's just used up as it goes along from one energy level to another. And we can see the little squiggly lines here. Some of that energy is lost as heat, but that energy is still out there. It's just in the form of heat. How is energy transformed? Radiant energy from the sun comes along, and then the sun gives its energy to the plants. The plants have a chemical in them called chlorophyll. Chlorophyll is the green stuff in plants. The chlorophyll then takes the energy from the sun. It breaks apart water molecules and carbon dioxide molecules, and it rearranges them into a wonderful tasting molecule called glucose, and that's sugar. So plants make sugar. That sugar is now a type of chemical. Sugar is a very tasty chemical. So the energy from the sun is now turned into energy that's in sugar. That's chemical energy. Then the chemical energy from the producers, well, it's made through photosynthesis. Then chemical energy from consumers eating the producers. So when you and I eat the plants, then we get that sugar that's in them, even if it doesn't taste sweet. You may think that a carrot or celery or lettuce doesn't taste very sweet, but there is sugar in there. And then we get that energy from the sugar. And then that gives us the energy to walk around, for our heart to move, for us to write and type and get up and get down. And all of that is mechanical energy. Anytime we're moving, that's mechanical energy, including your heart moving, that's mechanical energy. So the mechanical energy of consumers chewing their food, running, jumping, writing, typing, and all that turns into heat, because think about it, anytime you're moving, you're going to start to get a little bit warm. And so that's thermal energy. So the heat energy from friction of animal muscles moving around. So we went from radiant energy to chemical energy to mechanical energy to thermal energy. All of that, but we didn't lose any of the energy. It's all still here somewhere on Earth or somewhere in the universe. It may have just gone off into the atmosphere in the form of heat. So we went from one type of energy to another. What if it isn't edible? Think about I was talking about right here, the plants are edible, but what about things that aren't edible? Think about every step it takes to make an object work. Right here, there are chemicals in that battery. You put it in a flashlight, you turn the flashlight on. Now the chemicals are transferred into electricity. They go through the wire. Then they go to the light bulb and they turn into light. And probably it doesn't have it on here, but that light bulb is probably going to get a little bit warm, which is then thermal energy. So it went from chemical energy in the battery to electrical energy in the wires of the flashlight to radiant energy, that's light energy in the light bulb, and then that light bulb gets warm, so that becomes thermal energy. I don't know why they didn't put thermal energy on here, but that's all those different types. But it's the same energy. It's just moving from one form to another, one type of energy to another. So if it ends up leaving the battery and going through the wires, and then leaving the wires and going through the light bulb, and then leaving the light bulb and becoming heat, then it's no longer in the battery, it's no longer in the flashlight, it's no longer in the light bulb, it is out there in space. So don't think, oh wow, I can still have all of the energy in the battery and all of the energy in the wires of the electricity and all of the energy making light and all of the energy making heat. No, it just goes from one to another. And eventually, you know what happens. Eventually, when you've used up all the energy in the battery, it's dead and you throw it away. There is no more chemical energy in the battery because you've turned it all into electricity and then light and then heat, and it's not in the battery anymore. Spot the energy transformation. What's going on here? We have electrical energy coming through the wire. And then the propeller turns, the fan blades turn, and it moves the air. And that's going to be anytime something is moving, that's called mechanical energy. So it's going from electrical energy in this orange wire here to mechanical energy with the fan blades turning and the air is moving also. So the fan blades moving, that's mechanical energy. And then the air moving, that's mechanical energy also. What's the energy transformation here? Oh, we have food. Food is always a type of chemical energy. You eat it, and that gives you the ability to have your heart beat, your mouth move, your hands move, you're talking, your eyes are moving around, your body is getting up, you're running. That's going to end up, that's mechanical energy. So the apple right here and all the food has chemical energy in it. You eat it, that lets you move. So that's mechanical energy. And then when you move, that's going to end up making heat. And that's thermal energy. So we go from, we go from chemical energy in the apple to mechanical energy is chewing, but then it's also going to become thermal energy. That's not on here, but it turns into thermal energy, that's heat. That's why your body is warm, because your muscles are moving around in there. Energy transformation, oh boy, Buc-ee's. We're not talking about all the junk food that they have or the beef jerky that they have in Buc-ee's. We're talking about this thing right here. That's a gas pump. Gasoline is a chemical. It goes into the engine of your vehicle, and that lets the vehicle move. So it goes from chemical to mechanical, because anytime your car is moving down the road, that's mechanical. But then when that engine goes for a while, you know the engine is going to get warm. That's thermal. So it goes from chemical to mechanical, but then also thermal. And some of that chemical energy powers the electrical system in your car, and that lets the headlights run. It also lets the radio run and all that, which radio is a type of radiant light. You just can't see it. So there are a couple of different things going on here. Look at the power, oh boy. Look at the power cord right there. It's an electrical cord, so electricity comes in, and I wouldn't touch the top of that if I were her. I guess that's cooler up there, but you know what happens right here. Even if you're a guy and you don't use this, I don't use this. My hair isn't long enough. I don't have very much hair, but it's a curling iron. This gets very, very hot. How does it get hot? Well, you have to plug it in. So electrical energy becomes thermal energy. That's heat. Electricity becomes heat. Electrical to thermal. Right here, this is solar energy. That's radiant energy. And that gets turned into electricity. Radiant to electrical. Remember, radiant means light, so it's sunlight. If you'd said solar, that's okay, but radiant is a better answer. What's going on here? We have chemical. This is a little sparker right here. It runs off of a battery, right? So we have the batteries in here are creating that's chemical energy, and then they get turned into electrical energy, and the electrical energy ends up becoming light energy, and then the light energy is very hot, and that's thermal energy. Basically, that's what I already showed you with the flashlight before. The battery is chemical, then it goes through the wires, that's electrical, then it makes light, that's radiant, and then the light gets very hot, and that's thermal energy. And some light bulbs are hot enough to where they can start a fire. It can be a fire hazard. What's the energy transformation here? Where is the steam? Let's see. There's the generator over here. All right, so steam is going on over here. We have the nuclear energy over here, the uranium fuel. That's the nuclear stuff going on. So we have the heat. Actually, it's nuclear energy, then becomes thermal energy, and then the steam moves this turbine right here, which is mechanical energy, and then that ends up turning, that transformer, it ends up turning into electrical energy. So it goes, they left off nuclear energy, but it goes from nuclear energy right here where the uranium is into thermal energy, and that creates a steam. The steam moves anytime something is moving. That's mechanical energy. And then it turns this turbine right here, which is some magnets and copper wire. And anytime you move magnets near copper, and these are huge magnets, not just little bitty magnets stuck to your refrigerator, huge magnets and copper wire, whenever you move them near each other, they make electricity. And so we end up with an electrical current there. What's the energy transformation here? We have a battery right here, that's chemical energy, and it turns the drill bit right there, and anytime, if it's moving, then that's mechanical energy. So it goes from chemical to, oh, I left out electrical, sorry. It's chemical to electrical. There are wires in here and back here, and then mechanical. Energy transformation, la, 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 okay. You know, in this phone, she's got a battery. So the battery is chemical, and then it sends electricity through here, all right? That's electrical, and then you end up with sound energy right there. So it's, they left off the battery, but the battery is chemical energy. You know your phone runs on runs on a battery because you say, hey, my battery's getting low, can I charge it? So it's chemical energy in the battery, then electrical energy going through the wires, and then sound energy coming out into your ears. Okay, now please go back to Canvas and complete what is called the gallery walk. It is in the same tab that you, or the same day that you accessed this video. If you have any questions about how to get to the gallery walk, talk to your teacher, email your teacher, but it is in today's tab in Canvas. Thank you, and have a great day.